Hi everyone, welcome to Knowledge Center. So today we shall discuss about the case 3 of a mesh analysis. So let's take up that. So case 3, already we have discussed case 1 and case 2 in the previous session. You can go through my previous videos for that. So now case 3 can be understood using one simple circuit. So let me take an example here. So I have a resistance, say this is 2 ohms. Let me take this as 1 ohm. Let me take this as a 3 ohm. And again I will have one more resistance, 1 ohm, with one current source and resistance in series to that, and close this. Say this is plus minus 7 volt source. Let me take this as 7 amps, and I'll take this as 1 ohm. Okay, so I have given all the values over there. So first of all, let us understand what is this case 3 and how it differs from the case 1 and case 2. So in this part of a circuit, I have a current source in between these two loops. So I can identify loops here. First, this is, say I can take it as a loop 1, and the current flowing here I mention it as I1. Let me take this as I2, and let me take this as I3. So whenever current source is available in between the two sources, then I can consider this as a super mesh. So that is about the case 3. Super mesh is nothing but, it's in simple way we can say that whenever a current source is available in between two independent loops or meshes, then it is termed as a super mesh. So the advantage of this super mesh is we can remove this, and I can make these two, I can combine these two and make one mesh. That is called super mesh. Okay, now let's see how to solve it. So before removing this, because we have a 7 amps current, means that will be having an effect on the circuit. So I can't just open it, I can't just remove it directly. First we need to consider the expression of this, we need to consider what is the effect of this. So now look at this 7 amp source, the direction of source is given like this, and I1 and I3 are the current which is coming in concept of this part. So I can say this is direction of I1, whereas this is direction of I3, right? I can write an expression as I1 positive because both are in same direction. I3 is opposite, so I'll take it as minus I3 is equal to 7 amps. So this is going to be an expression 1. So that is the effect of current source on the circuit. So I got that expression. Now we can, after getting it, you can remove this. You just remove this. Okay. And now what we did, I have these two and I don't have any barrier here, I have removed that. So I can consider this loop as this mesh as a super mesh. So I can say A, B, C, D, E, F. So A, B, C, D, E, F, A. This is a super mesh. Super mesh is nothing but a combination of two individual loops. That can be possible only if we have a current source in between those two loops. So now let's see how to write an expression for the super mesh. So before writing an expression, we need to mention the polarity for all the resistances and sources. So I have positive here. So let me take this as plus, minus, plus, minus, plus, minus. Okay. So now let me start from A to B. So A to B, I don't have any elements, so no voltage drop. Then B to C. See, B to C, I have 1 ohm resistance, I'll write it here, 1 ohm resistance, and we have current I1 and I2, but both are opposite to each other, so I'll write, and this is plus to minus, it is moving, so I'll take minus 1 into I1 minus I2. Then next plus to minus, so minus 3 into, what are the current we have here? This is I3, so I3 is in this direction, I2 is opposite to that, so you can take it as I3 minus I2. Then we have plus to minus 1 ohm, 1, and the current we have here only is I3. Then E to F, I don't have any element. F to A, I have an element. Minus to plus, so plus 7 volt equal to 0. So now, if we simplify this, we have I1, okay, only one I1 we have, so this is going to be minus I1. Okay, minus into minus plus I2, minus into minus plus I2. Okay, so here 3I2, here 1I2, plus 4I2 I am going to get. Next, we have minus 3I3 minus 1I3. So minus 4I3 is equal to minus 7. Yes, this is what we can write it as an expression 1. So now, after writing this expression 1, let's see about the second loop which we had here. So for this I will write expression here because you can't see this. Let me use this portion now. Okay. So for this we need to consider the separate polarities. So let me take I2 is moving like this. So I will consider this as plus, minus, plus, minus, plus, minus. So now let me take this portion now. First C to B, then let me name this as G. C to B, plus to minus it is moving. So minus 1 into I2 and I1 is opposite. So I2 minus I1. Then B to G, no element. G to D I have element minus, plus to minus it is. So minus 2 and only current here is I2. Then again here D to C we have plus to minus, so minus 3 ohm, and current I2 and I3 are opposite. So I2 minus I3 is equal to 0. Now after expanding this we get minus 1. First let me write I1 parameter. So minus plus I1, minus I2, minus 2I2, minus 3I2. So totally 3 plus 2 5, 1 6. So minus 6I2. Then we have minus plus 3I3 equal to 0. So this is going to be an equation 2. I got equation 1, equation 2, and this you can name this as an equation 3. So simplifying this, we get all unknown parameters I1, I2 and I3. This is all about super mesh. So I hope it is clear for you. So I'll make it very simple now. Case 1 means we consider only the voltage sources in a circuit. If we have only voltage sources in a circuit, just simplify by applying KVL. In case 2, we got a current source in the outermost loop or outermost mesh. Then we consider that loop current is equal to the source current. Whereas in case 3, we have current source in between two loops, that is considered as a mesh, super mesh. So if we have super mesh, we can combine those two and make one loop, one super mesh loop, and have one expression for that. And we'll have current expression like this. So this is all about the mesh analysis, and I hope it is clear for you. Just please subscribe to the channel and share among your friends. Thank you.